the bearing from Atlanta to Macon is south 27 degrees east, and the bearing from Macon to Augusta is north 63 degrees east. An automobile traveling at 62 miles per hour needs 1¼ hours to go from Atlanta to Macon and 1¾ hours to go from Macon to Augusta. Find the distance from Atlanta to Augusta. So we're just looking at examples of applied trigonometry, and in the process we've learned the meaning of these bearing directions, which is pretty cool to learn, but we're really just learning it as an illustration of applied trigonometry, which is still really helpful to see ways in which trigonometry is used. So, okay, these directions are, so you look at it like the first is given either north or south. This first term is going to be an N or an S, specifying north or south. Then next, you're going to have an acute angle followed by either east or west, which is just meaning the acute angle off the north or south line, whatever specified, in either the east or the west direction. Okay, so let's see. These measurements we can assume are coming from a common point. Okay, and so this is north, south. The bearing from Atlanta to Macon is south 27 degrees east. So south and then 27 degrees off south in the east direction. So something like, we're just going to draw the direction here. Okay, and then the bearing from Macon to Augusta, wait, okay, that's Atlanta to Macon. So, okay, these measurements aren't coming from the same point. This is Atlanta here. And let's say that this is Macon. We don't know, we don't know the distance, but that's Macon. And then the bearing from Macon to Augusta is north. So let's draw another, let's see. So we've got, okay, and we could draw thicker lines here to distinguish between the direction lines. So, okay, from, let's see, where are we at? From Macon to Augusta is north 63 degrees east. So in the north direction, and then 63 degrees in the east off of that direction. So if this is 90, this is 45 about, so this is 63. Okay, in Augusta, let's just pick a point, is like, here. Okay, so we're trying to find the distance from Atlanta to Augusta. Well, okay, we've got two A's, so A-T, A-U. So what is this distance is what we're trying to figure out. Call that X. We'll call this A and this B. Okay, we could draw some horizontal lines here. All right, so let's see. We've got, so Atlanta to Macon was south 27 degrees east, so this is 27 degrees. Macon to Augusta was north 63 degrees east, so this is 63 degrees. Okay, now what else? Well, we could get these some of these distances, it looks like A or B or both, with, yeah, we've got an automobile traveling like from Atlanta to Macon at 62 miles an hour, and it took 1¼ hour, so we can get the distance A. And then we could also get the distance B. So yeah, let's go ahead and do that. So going from Atlanta to Macon at 62 miles per hour, and then traveling for 1¼ hours. So 62 times 1.25, 77.5 miles. So that is this distance. Okay, now going from let's see. Yeah, now going from Macon to Augusta, it was same speed, but for 1 3/4 hours. So 62 miles per hour, same speed, but traveling at that speed for 1.75 hours. 108.5 miles. Okay, so now we need to solve for x. And this is going to set up to be a trigonometry problem. So we know based, we can put two and two together, and we know that this is going to be a right triangle. But in general, for problems like this, you don't necessarily have right triangles. So it's good to know geometry in general. But okay, let's see what other angle information we can get. We've got two parallel lines here cut by this transversal. Okay, does that, well, what about this? We've got these two parallel lines cut by this transversal. Yeah, so that means that this is 27 degrees, opposite interior angles. So what's 27 plus 63? 90. So there we go. This is a right angle, so this is a right triangle. And in general, for these types of problems, it's like a coincidence that we happen to get a right triangle. Usually, I would imagine for most types of problems like this, in some situations, it's the way like the design of the system is set up. You always get a right triangle, but in general, it's good to know geometry, not just trigonometry, but it's good to know both. So, okay, with that, all we need to use now is the Pythagorean theorem. We've got two sides. We need to solve for the third side. Well, what side is this? Well, opposite of the 90-degree angle is the hypotenuse. So this x is the hypotenuse. So Pythagorean theorem, x squared is equal to 77.5 squared plus 108.5 squared. Take the square root of both sides. So about 133 miles. 133.3.